So it says to use transformations to graph f of x equals 4 to the x plus 4, right? And we know what 4 to the x looks like. So we want to graph the equation and the asymptote. Graph the asymptote as a dashed line. Okay, so first we have to know what 4 to the x looks like. So that's supposed to be one of your parent functions. We can do that one. Let's do that one in black. So y equals 4 to the x. If I make a little xy table, I can get a few points to see what that looks like. Or you could use your graphing calculator or Geogebra to get an idea. So let's see, if x is 0, 4 to the 0 is 1. And if x is 1, 4 to the first is 4. And that's as far as I'm going to go because my y-axis only goes up to 8, and 4 squared would be 16. But I should do -1, right? That would be a fourth. And -2, that would be -1/16. All right, so if I plot these points, I've got 0, 1, and 1, 4, and -1/4. So it's like a teeny. Oh, this is hard. That's good enough. Just say it looks like this. Okay. So now if I want to graph 4 to the x plus 4, that plus 4, is that an inside or an outside change to the equation y equals 4 to the x? Outside change, and you were just saying that means it's going to go vertically up. Yeah. So any kind of outside change to the equation is going to be a vertical change to the graph. By inside and outside, I don't know if Linda used that same language. 4 to the x plus 4, I think of that as an outside change versus an inside change where you change the x. If I had written the plus 4 with the x, I think of that as an inside change, right? So outside versus inside. Outside changes are vertical. Inside changes are horizontal. Okay. So this is a vertical change. Adding and subtracting means shift. So this is going to shift up 4 units. Okay, so I'll choose a different color to do this one. So this was at 0, 1. Now it's going to be at 0, 5 because it's going to go up by 4. And this was at 1, 4. Now it's going to go 1, 8 because you have to add 4 to the y-coordinate. And instead of -1/4, it's going to be -1, 4 1/4. And my asymptote, okay, this horizontal line that my graph approached but never crossed, used to be at 0. If I shift everything up by 4, where's it going to land? At 4, yeah. It used to be at 0, now it's at 4, so I've got a horizontal asymptote here. Dashed line, and then the rest of my graph looks something like this. Does that make sense? All right, so we have a rational function 30,000 times x minus 14 over x squared minus 9 minus 8x. It models the number of arrests f of x per 100,000 drivers for driving under the influence of alcohol as a function of a driver's age x. Okay, so out of every 100,000 drivers of a certain age, we can figure out how many arrests there are for driving under the influence using this function. So you're supposed to graph it in this viewing rectangle, and which one is correct? Okay, so this is, in all of these, the viewing rectangle is 0 to 70, going by 5s. 0 to 70, 0 to 70. 0 to 70, right? Okay, so and then the y is 0 to 400. Sorry, 0 to 20. Nope, 400. 0 to 400 by 20s. Okay, so the first thing I'm going to check is x-intercepts. Where does it cross the x-axis? And that happens when the function equals 0. So where does f of x equal 0? What makes a fraction 0? What part of the fraction has to be 0 for the fraction value to be 0? Close. The numerator. Yep, when the denominator is 0, it's undefined, which usually gives you some kind of asymptote, right? When the numerator is 0, the whole fraction is 0, right? 0 divided by anything is 0. So all I have to do is set my numerator, 30,000 times x minus 14. Oh, but then I have the minus 8x. I have to do the whole thing. Sorry. I didn't realize that I forgot there were two parts. So I'm going to set my whole thing minus 8x has to be equal to 0. All right, so I think I'll add 8x to both sides. Now what would you do? We're trying to solve this thing for x. Oh, thanks. Yeah, I can multiply both sides by the least common denominator, which in this case is x squared minus 9, right? Or if you prefer, you could think cross multiply, right? Just two fractions that are equal. All right, so let's see, 30,000 times x minus 14 times 1 is 30,000 times x minus 14. And then x squared minus 9 times 8x is 8x cubed minus 72. You know, an easier thing to do. Okay, so I get to this point and I go, oh, it's a cubic. I don't have a special formula to find the solutions to a cubic, right? I could do it if it was quadratic, but cubic is harder. So my instinct is to not pursue this track any further. So I am thinking to myself, okay, this is multiple choice, right? And so I have candidates for zeros for x-intercepts. I could just plug them into the equation and see if they really are x-intercepts. Okay, so let's just forget all this. And let's see, if option A here goes from 0 to 70 by 5s, that looks like it's going to be 5, 10, 15, 20, 25. 30, 35, 40, 45, 50, 55, 60, 65, and this one is like between 60 and 65. Somewhere in between there. And then for this graph, it looks like I have a 0 at 5 and 10, 15, 20, 25, 30, 35, 40. And this one looks like 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, between 50 and 55. And then 5, 10, 15. And this looks the same, 50 to 55. Okay. So I'm just going to get my calculator. That's all I wanted. C based on graph. Oh. Yeah, so let's see, this has to be C. Check. Okay, good. All right, and then we're supposed to describe the trend shown by the graph. Okay, so the graph shows a rapid increase as x approaches a maximum in the lower half of the domain. All right, so the domain is all the x values that you can plug into this function, which means we have to take the context into account here. So x is driver's age, right? So the lowest a driver's age can be is, depends on the state, but I think it's like 15. It might be the lowest in the country, right? And then the oldest it could be is, however old a person can drive till or live till. So, I don't know, 70, 80, 90. So my domain is like 15 to, let's just say 100 or something. Okay, so the lower half of the domain is going to be 15 to middle age, right? So yeah, it increases very quickly. So here's the domain of 15 starts about right here, and it goes up very fast, right? And then it slowly decreases until you hit be somewhere between 50 and 55, right? And then there's seems to be none. So a rapid increase as x approaches a maximum in the lower half of the domain, and then a gradual decrease as x increases past the maximum. I think that's the one. From 15, it increases fast. 20, 25. So it looks like the maximum happens at about 25. Those are the people who have the highest incidence of DUI arrests. And then it gradually decreases. All right, it says use zoom and trace to find the maximum and use your graphing utility. Okay, so I'll show you how to do it in GeoGebra and on your graphing calculator. So in this guy, in GeoGebra, you can just type, I think you can just type max. Let's just do extremum. I know you can do extremum. F of x. Okay. Function start value and x value. Okay. So we know that it happens around 25. So we're going to do f of x. And then you have to give it a region to look for that maximum value. So we'll say it happens between 20 and 30. And it'll find the maximum value in that interval. So we have that point, that very highest point is point A, and it happens at 24.04, 337.1. 24.04, that's the age, and 337.1, that's the number of arrests per 100,000 drivers. Extremum, yeah. Let's just try maximum just for fun. Max f of x, comma, 20, comma, 30. Yeah, you do the same thing with max or min. Extremum is just a fancy word that means max or min. Look for a max or a min. All right, so the answer here would be the age that corresponds to the greatest number of arrests, round to the nearest tenth, so that would be 24.0. 0.04 would round down. And then the number of arrests for this age group out of 100,000 drivers is 337.1. All right, so that finishes it. That makes sense? Okay. I should show you on a graphing calculator too, just in case you need to do that. Because I know some of you use the graphing calculator. So we go to y equals, we're going to type in the function, which was 30,000 times x minus 14 divided by x squared minus 9 minus 8x. All right, so then I have to choose a good viewing window. So remember, x is representing age, so the lowest it can be is 15, but I think I'll start at 0 just to get a good picture. And the highest, let's just say like 75. And then for y's, this is number of arrests per 100,000, so 0. I'm kind of cheating because I already know what the maximum is. It's like 300 something, so I'll go to 500. All right, and if you want the maximum value here, it's in the calculate menu, which is above the trace button. Hit second, calculate. One of the options is maximum. And then it asks for a left bound, which means move this cursor anywhere to the left of the maximum. So anywhere to the left, and hit enter. And then it asks for a right bound, move that cursor anywhere to the right of the maximum, and hit enter. And then it asks for a guess. You just have to have this cursor. So this arrow is your left bound and this arrow is your right bound. You just have to put the cursor anywhere in between those two and hit enter. And it gives you the 24.03 and the 337.1. So zoom and trace, so I'd hit zoom. I like to use the zoom box. So you can just draw a little box around the spot that you're interested in. So I can zoom in on just this maximum. And you could do this over and over again to get a really good zoomed in picture of the highest point. Yeah, and then you could just trace if you want. So we've got this, so 24, it's getting bigger, 24.01, 0.025, 0.036, 0.04, 0.05, 0.06, 0.07, 0.09, 0.1, 0.11, 0.12, 13, 14, 15, 24.2. Oh, sorry, these are x values. I'm looking at, I need the y values. I need the highest y value, right? So just look at these y values, this 337.095, and look, see if it's getting bigger, right, as you move to the right. 0.0977, 0.099, 0.1, 0.101, 102, and then it starts getting smaller. So if you were to measure to the nearest tenth, it would be 0.1, and then your x value is 24.04-ish. Yeah. So you could do zoom and trace. It's just, I wouldn't. Just use the maximum, find the maximum. Graph f and g in the same coordinate system. Graph and give the equation of the asymptote. So 7 to the x and 7 to the negative x. All right, so if I'm going to graph these, maybe I'll just use Geogebra. Cookie tool. Okay, so we'll have f of x equals 7 to the x. And that's not a very good window. So I'll adjust this. All right, that's pretty good. And then I'll have my other function be g of x, and that'll equal 7 to the negative x. And this one, I'm just going to change the color so we can keep track of them. All right, so this one, the black one is 7 to the x, and the pink one is 7 to the negative x. And the asymptote on both of them looks like it is the x-axis, right? And what's the equation of the x-axis? Y equals 0. Good. Okay, so 7 to the x should be 0, 1. There's 7 to the x. And then 7 to the negative x is the reflection of this guy over the y-axis. And the asymptote for both is y equals 0. In my math lab, okay. Okay. Graph f and g. All right, so we'll use an exponential tool. And I want 0, 1, and 1. Oh. Okay, so yeah, this is 0, 1, base 7. Okay. And then all I want to do is reflect over the y-axis. Oh, okay. All right. There we go. 0, 1. Reflect. Check. Oh. What do you want me to do? Oh. Gonna graph the asymptote. Okay. 1. Okay. Yep. Yeah. That's a pain. All right, so let's see if I wanted to do this again. 5 to the x and negative 5 to the x. So exponential tool. 5 to the x would go through 0, 1 and have base 5. Yep, good. Okay, so then I do exponential tool again. And this time it's going to reflect over the x-axis. So let's just do that. Reflect over x. Okay. And then choose the line, but make it dashed. There we go. So you just got to play with it a little bit till you figure it out. Evaluate without a calculator if possible. Okay, so it's log base b of x cubed y over z to the 4th. So we learned a couple of log properties this week. Let's see, so some properties that might apply here are that it looks like I've got some multiplication and I've got some division and I've got some powers. So those are 3 properties of exponents. If I want to take the log of a product, right, I can take the log of each number separately and add them. Right, so that's one property. And then my property for division, when you want to take the log of a quotient, division problem, you can separate that into 2 logs using what property? Yeah, subtraction. I didn't mean to say property, I meant to say operation. Thanks. Yeah, so this is becomes log A minus log B. And if you have an exponent, log of x to the p, something like that, the property says that you can take that p, that's the power, and bring it down in front of the log. So this becomes p times log x. So I'm going to have to apply all three of these, and my advice is going to be to just do one at a time, right? Don't try to do all of these at once. So I'm going to put this on a new page so I have room. Okay, so the first thing I see that jumps out at me is the division, right? So I'm going to get rid of this fraction by rewriting this as a subtraction problem instead of the division. So this is going to be log base b of x cubed y minus log base b of z to the fourth. All right, so it's just one thing. I just simplified the division part. All right, so looking at log base b of x cubed y, I want to deal with the multiplication. And why am I going to do the multiplication before the power? Before dealing with that cubed thing. The power will go in front, right? But to use that property, if I wanted to use that property here, it would have to be log base b of this whole thing cubed, right? But this just the x that's being cubed. So I got to separate it out before I can use the power property. All right, so because this is multiplication, I can rewrite this as two logs using addition. So this is going to be log base b of x cubed plus log base b of y, and I still have minus log base b of z to the fourth. Then I can use my exponent property on that one and that one. Just bring those down in front. So my final thing is going to be 3 log base b of x plus log base b of y minus 4 log base b of z. Okay, so your first step is to classify, and this is often given, right? This is often told what kind of function you're going to use. Okay. If you're not told, they might have to give you a lot of data points so that you can look at the data points and decide what function would fit it best, right? But you're generally told what kind of function to use. And then each of these functions has its own formula and its own rules for how to find the equation of it, right? So for a line, you would use y equals mx plus b. And then if you're given 2 points, you can find the slope and you can find the y-intercept, right? If it's quadratic, usually the easiest thing to do is to use Vertex Form, where hk is the vertex, and then you solve for a using another point. Polynomial, if you know the zeros, the easiest thing to do is to set it up where you do factors. Each factor is going to be x minus a 0. And then there's some unknown leading coefficient a. Piecewise is just going to be, you know, a combination of any of the other ones. Rational and exponential. So let's see, rational. Rationals are trickier, but it's basically going to look like a fraction, right? And then in your numerator, you're going to have x minus zeros. And in your denominator, you're going to have x minus vertical asymptotes. The exception to this is if you have holes. But that's generally how you do it. And then for exponential, it's going to be y equals a times b to the x. And there's only two unknowns here, right? You have to figure out what a is and you have to figure out what b is. So if you have 2 points, you can just plug in x and y, and you just need 2 points and you can solve a system for a and b. So it's different for every kind. Yeah, so you have to be given 2 points, like, 0, 5 and 1, 10, something like that. Plug in the x for x and the y for y, and then you'll have a system of equations you can solve for a and b. So let's look at this one, right, from the quiz. Number 1, part F was to use this information to write an equation of the lowest possible degree. So this is a polynomial, and they told us that in the very beginning. It says this is the graph of a polynomial function. All the important features are shown, which means all of its zeros are showing. Right? So this is a polynomial, which means I can generally write it like a times a factor, times a factor, times a factor. Right? And each factor is x minus a 0. Right? And then my zeros are -3, -1, and 2. So x minus -3, -1, and 2. And then I don't need this last guy. Oops. All right. But if you were to multiply this all out, you would have, well, this is x plus 3, x plus 1, x minus 2. Okay, if you were to multiply that all out, x plus 3 times x plus 1 times x minus 2, what would the highest power of x be? 3. But what's the end behavior of a cubic look like? One should be up, one should be down for an even degree, or for an odd degree, right? But the end behavior of my graph, both are down, which means that the exponent has to be even. The degree has to be even. So what did I miss? What little subtle thing did I miss here? Yeah, that 0 right there at -3, it bounces off the axis, which means it has even multiplicity, which means it's a 0 at least twice. So I need a 2 right there. I gotta square that one. Okay. So now I have a 4th degree polynomial that has all the appropriate zeros. The only thing I don't know is this value of a. How do I figure out that leading coefficient? What is that? It's definitely negative because the end behavior is pointing down, right? So it's got to be negative. So that's good. Okay. How could I be more exact? How could I find exactly what negative number it is? I will solve for it. Yeah, I'm going to solve for it using a point. Any other point that I know, if I plug in the x coordinate for x and the y coordinate for y, will make this equation true. Right? So if I put in 3 for y and 0 for x, then the only unknown in that equation is an a, and I can solve for it. So this is 3 squared is 9, times 1 is 9, times negative 2 is negative 18a equals 3. And so a has to be negative 1/6. So that's going to be your final equation. Y equals negative 1/6 times x plus 3 squared times x plus 1 times x minus 2. Yeah, yeah. Yep, that bounce off indicates an even multiplicity, right? Which means that negative 3 is a 0 either 2 times or 4 times or 6 times, which means that x plus 3 has to be a factor 2 times or 4 times or 6 times, an even number of times. And in this question, I asked you to use the lowest possible degree, which is why I just put a 2 and not a 4 or a 6. Or not necessarily, not necessarily. It just wouldn't quite be following the directions, but yeah. All right, let's see if there were any other find an equation. Oh yeah, number 3. Okay, so number 3 from the quiz. Find an equation, and it says determine an equation for the quadratic, right? So step 1 of find an equation problems is to determine what kind of function it is, right? So this is a quadratic, right? And then once you know what kind of function it is, you have to figure out what is the formula, the typical formula for that kind of function, right? So in this one, when we said it's a polynomial, its typical formula is a times x minus a 0 times x minus a 0 times x minus a 0. But for a quadratic, the standard formula is a times x minus h squared plus k. And h and k are the coordinates of the vertex. So all I have to do is plug in a 3 for h and a 4 for k to start. So I've got a times x minus 3 squared plus 4. So then the only thing I still need to figure out is what is a. Exact same thing I did in the last problem, right? Take any point, plug it in for the x coordinate for the x's and the y coordinate for the y's, and you can, the only thing missing then will be the a. Okay, so I have this point 4, 8, so I'll put in 8 for y and 4 for x, and then the only unknown is a, and I can solve for it. So 4 minus 3 is 1, squared is 1, so 8 equals a plus 4, so a is 4. So your final equation is going to be y equals 4 times x minus 3 squared plus 4. That's okay. So this one's the vertex. The vertex is a special point in a quadratic, right? And it's h comma k. So if you have a parabola, if you know it's vertex, all you got to do is throw it in for h and for k. Right, but this says a times 1, so this is 1a plus 4. You can't combine them because they're not like terms. Yeah. All right, and then this one is just any other point. Right, once you've plugged in your h and your k, we have to figure out what a is. That's the only unknown left. So you take any other point, put in the y coordinate for y and the x coordinate for x, and you can solve for the a. Then once you know what a is, you go back to your original formula, right, this guy, put in your h and your k for your vertex, and the a you just solved for. Mm-hmm. Yes, this is the standard vertex form. Polynomial form is just if you multiply this out. So I would multiply x minus 3 times x minus 3, because that's what x minus 3 squared means, right? So if you FOIL x minus 3 times x minus 3, you get x squared minus 6x plus 9. Right? And then I'm going to distribute this 4. So I get 4x squared minus 24x plus 36. And then I still have the plus 4. And then combine like terms. 4x squared minus 24x plus 40. That's your polynomial form or your multiplied out form. Looks like ax squared plus bx plus c. Yep. We're supposed to find all the zeros of this cubic polynomial. And because it's cubic, how many zeros am I looking for? 3. So I know there should be 3 zeros. Right? All right, and 1 comma 0 is an x-intercept. And x-intercepts and real zeros are like synonyms, right? So they've given you 1, right? Which means one of them, oops, one of them is x equals 1, right? The x coordinate's the only one that matters there. X equals 1 is one of my zeros. Okay, so that means x minus 1 is a factor. So to find another factor, I can divide. Right? I'm going to divide x minus 1 into x cubed minus x squared plus x minus 1. So look at the leading term. What do you multiply x by to make x cubed? X squared. So x squared times x is x cubed. X squared times negative 1 is negative x squared, and subtract. And that goes away, and that goes away. They both fall out. So then you bring down the rest of your divisor, or dividend. And then x goes into x 1 time. X minus 1, subtract, and you get 0. So I know that f of x can be written as x minus 1 times x squared plus 1. So if I FOIL that out, I should get this cubic. So then you could set each factor equal to 0, because we're looking for zeros, right? So if I set this whole thing equal to 0, I know x minus 1 is 0, or x squared plus 1 is 0. X equals 1, already knew that. Or x squared equals negative 1. To finish solving that, you square root both sides. And then we get x is, what's the square root of negative 1? I. Yeah, so you plus or minus I are your other two zeros.